f of x equals 2 times x minus 3 quantity squared minus 1. What is the vertex? Look at that. See if you can tell me what the vertex is. V for vertex. I heard -1 as a second coordinate. What did you say for the first? 3, right? So for h, you look at what you're subtracting from x to get h. So you kind of go opposite of what the sign is, right? For h. For k, you go with the sign. So it's, you think of it as -1 is plus a -1. So k, you're going to include that negative. So you just kind of have to remember that. Okay, now let's plot that point, and then let's decide on one other point to plot. So we're going to plot 1, 2, 3, -1. Does it open up or down? What's the value of k? Of a, sorry. What's the value of a? 2. Is that bigger than 0? Yep. So is this a smiley face or a frown? It's a smiley face. It opens up, in other words, right? So you kind of know what this graph looks like, right? A little bit. It starts at that point I plotted, 3, -1, and goes up from there. That point is the low point, isn't it? So just plot one point whose x value is close to that point. So in other words, you're going to plot some points, x, y, y equals f of x, right? So pick an x value close to the x coordinate of the vertex. Well, what's close to this position of 3? How about 2? Okay. Plot 2. It's not hard to plot 2. You plug it into this equation for x. So if you plug in 2 and subtract 3, what do you get? So you're finding f of 2 essentially. Just do the first part for me. What's 2 minus 3? -1, but then you square it, multiply it by 2, and subtract 1. What is that going to get you? Well, -1 squared is 1, times 2 is 2, minus 1 is 1. So you know 2, 1 is on the graph right here. And I claim you don't have to do any more calculations because you know about the axis of symmetry. The axis of symmetry, remember, is the line that cuts this parabola in half. What would the equation of this line, be, by the way, be? X equals, what horizontal position is it at always? H, which is 3. You should be able to find that. If I ask you for the axis of symmetry, you should be able to name it if you know what the vertex is. AOS. So using that axis of symmetry, we can get another point in the graph just by thinking about it this way. Okay, this point that I just plotted, it'll have kind of a mirror image point on the other side of the line, same distance away, same height, same distance away. So it's here. It's right here. Just go a distance of at the same height as this point, go a distance of 1, because that's how far this point is from the axis of symmetry. And what point is that? It's at 1, 2, 3, 4, 1. This is your symmetric point. You got it using symmetry. You got it for free. Okay, what do you do then? As long as you have the vertex as one of your points, 3 points is enough to get a decent looking graph. Draw the smiley face. There you go. What's the domain? Yeah, so that's not very interesting. That's always going to be the same for these parabolas that we're drawing. What's the range? How low does it get? How high does it get? There's the low point, or low value, right? -1, including -1, it actually gets to that height, right? Think low to high. Look at the graph. Think low to high. How high does it get? Infinity and beyond. No, just infinity. And then does it have a min or a max? It has a minimum value, right? What is that minimum value? -1. So you should be able to name all these things: domain, range, axis of symmetry, the minimum value, and of course be able to graph it, be able to name the vertex, of course. You need that to graph it. Okay?